Hi, good morning, everyone. Good morning, everyone. So, we are starting our week five workshop. This workshop having the content with the regression analysis, and that we are learning some basic concepts about the regression analysis and how to predict the model by using the independent and dependent variables. So right now we are learning what is the concept of regression. So we have already learned the basic concept in our practical, and also we learn during our class lecture class. So this is the workshop. We are learning practically how it's works, and I will try to explain the basic concept of regression, and also will explain the regression model. So now we are learning about the what is a regression model. So that by definition, if you say like this is the predict the value of the dependent variable based on the value of at least one independent variable, like we may have one independent or more than one independent in the same model. So we are dealing the combination of the dependent and independent variable. So of course there are different examples, just like income and expenditures. Either our expenditures are depending on income, and also there are a lot of other things like demand and supply, prices and demand, and so a lot of different variables having the impact on another. So if the one variable is having the impact on another, so means one is depending on other. So this is the we are checking the impact of one independent variable on some dependent variable. So this is the concept of regression analysis or regression model. So we have in the linear regression model. So usually we say we have a simple linear, and we have multiple linear regression. So right now we are learning the basic level of simple linear regression model. So simple linear regression model, when we have one independent variable and the one dependent variables at the same time. So we are checking the impact, the causal change, like how much the variables are actually changing from the variation within the data having the impact on another variable. So now we are uh, simply understand about the basic concept, how it looks like. So the linear relation usually having the straight line. So if there is no linear, means it's a curvic, or having no you can say having some quadratic or cubic relationship. So linear means we have a, simple equation like y is equal to a plus bx. Just like you can say simple linear regression having a straight line equation, or you can say we have a straight slope. Even you can imagine variable maxima having the power of degree is 1. So, if the power degree is 2 means it's a quadratic equations, a quadratic model. So, we are discussing right now about the linear. So, left side the diagram, you can say these are having the linear relationship, and one is direct and other is indirect or negative linear relationship. On the right side, you can say the top one is actually having the curvic relationship, non-linear relationship. Also, you can say quadratic somehow relationship, or the last diagram on the right side, you can say it's a, constant behavior, no change or no relationship within the data. Now, we are understanding about the linear regression model. This is the population model. This population model says like we have a beta naught plus beta 1 x is equal to epsilon. Epsilon is actually showing a random error, or we can say residual, which is actually showing some errors coming within the model. So, how much, how you can say like error in the model. So usually when you are taking a sample and taking the information from any scenario, even you are taking a full sample, but you cannot say that you are incorporated all the independent variables in the same model. For example, income and expenditure. So X is representing a income and Y is representing expenditures. So, do you think like you are running a full model? No, because expenditures not only depending on income, expenditures are depending on your bonus, expenditure depending on your behavior like living and how much you are spending in different ways. Income is coming in different way. So like of course the number is also depending on your family members. If you have a small family, you have of course you have a less expenditures, and if you have a big family, so yes, you are living in the joint family, so of course your expenditures are more than the other families. So that's why at this moment you are taking only one independent variable. So at that time, like you can say we are having we can face some challenges, or we have some random errors within this model. So to incorporate particular context, like we can consider like right now 95% confidence interval, like we are 95% confident to run this model. So, for example, we are not confident with the 5% means we are facing some challenge right now. We are assuming like 5% maybe the error can be happened. But right now, this epsilon is not directly having the impact with 5%, 95%. We can estimate or calculate the population based residual, what is the expected random error. So right now, this is the basic concept, the linear components like usually beta naught also represent the as B naught and something like that. So usually every book have the different notation. So that's why you must understand the basic notations, and then in the meanwhile you can easily interpret accordingly. If we are considering the sample model, like see, this is the estimated or you can say sample based model. So usually beta naught is converting to the beta b naught, and the beta 1 is converted to the b1. And also we can use the beta naught as a usually we are using a plus bx, and we to avoid the b naught or b1, so you can easily change the notation and replace b naught with a. Okay, right now we are understanding about the basic concept, like we have one independent and one independent variable. That's why we can say it's a simple linear regression model. So if we have a multiple independent variable, then we can say it's having we are checking the two or three different independent variables impact on dependent variable. Right now, of course, our individual random errors, which is say EI, have the mean of zero. So this is the assumption of regression model. Right now, we you can see like what is the B1? B1 is a slope, and this is the regression coefficient. These are the formulas how to calculate, but we are not going to the manual calculation. This is just a understanding how to calculate, right? So you can easily calculate by using different softwares, just like Microsoft Excel and also other softwares. So you can calculate, and then you can just if you are using in your assignments and somewhere else, you can use and take these values and just explain the particular thing. Okay, now we are explaining what is the meaning of B naught and what is the meaning of B1. B naught is actually the value, you can say it's intercept. Intercept, usually we can say average value of the y when the x is 0. So this is the standard definition of intercept, which is B naught right now. So I will explain in detail with the different example. Just like I can example give a one example right now about the. For example, you want to establish a cost function. So cost function is depending on the fixed cost and the variable cost. So of course, for example, the we can say the fixed cost is beta naught intercept and the variable cost is B1. So at the moment, you can develop a regression model by using the cost for the cost function. So you can easily say like what is the initial cost or starting cost, the investment expenses, that is also say like a fixed cost. So this fixed cost is usually say our intercept. So, and also, what is the variable cost? Variable cost is the daily expenditures. Like if you are running a business and you are started is a new startup. So, first time investment is actually the fixed cost, and if you are uh, spending the daily transport expenditures, daily groceries, something like that. So, this is actually the variable cost, which is called B1, or you can say regression coefficient, which is having the variation with the monthly or daily, monthly, or whatever the model is says. For example, you are running the model by using the 1 month data. So, of course, you can say it's a month. Weekly with bi-weekly or weekly or monthly, whatever the data says, you can easily explain accordingly. Right now, we are explaining in detail what is actually we are measuring. So right now I have example. So we have a real estate agent wishes to examine the relationship between the selling price of the house and its size. So we have two variables, like one is house price in 1000 unit, and also we have square feet. And we have 10 houses and we want to check the impact. So how we can, so we have a data, and this data representing the 10 houses with the square feet prices. So now we can go to the data and data analysis. This is the X and Y. So you can click the label because we are selecting the label in the first row. So you can also put the output range. Output range, usually I'm just using the output range in the same sheet. And then if you want to check the normality plots and also residual and residual plots, so you can easily just checking these ch checks button. So then press OK, then you can get this model. So this model is very interesting. Like we have a positive impact of square feet on house prices, means when we are increasing the square feet, and then of course we our house prices are increasing. At this moment, we need to explain three major components. Like first is model. So this model is very, very important. So that's why we first see the what is the model says. So this is what the model says. We are learning first. So this is a model. How models comes? This is actually we can say this is B naught. I'm just writing by using my keyboard. So this is B1. So B1 and beta B naught is says like we have a intercept with a 98.24833 and the square feet you can say it's regression coefficient B1 is 0.10977. So one thing is very important. You need to understand the unit. So right now the what is unit? Unit is 1000 unit. If you are considering square foot is a 1000 unit. So when you will explain, you need to explain in a 1000 unit, right? So you can easily see like we have a 98. So there is a 98. So we are writing B naught here, and this is a B1, and this is the independent variable as X. So, for example, if you want to explain, so one unit increase in square feet, how much we are facing, like this is the positive sign. Positive sign means the increasing. If the negative sign means decreasing. Right now, if we are having the one unit increase in square feet, 0.10977 times the house price is increasing, right? So this is the simplest way to explain, right? So this is also we will use the on average increase, right? Because we are talking about the whole data. Okay, so this is the one way. So I will explain another way explanation, because right now this is a square unit. Sorry, is 1000 units. So you can explain in the other way as well. Now I'm explaining another important thing, which is R square. R square is actually showing the model strength, how much the model is strong, like predicted power, and how much yes you can predict the model, like how much the variation explained from the independent variable to independent variable. There are different books having the different definitions. Usually business students are understanding in the different way. Just like 0.58 means 58% model is strong, right? So your business model is strong with the 58%. Okay, how you can understand about that, like 58% is strong means should 50%, 58% is utilization means the model is not explaining 42% of your like why, because house price is not only depending on square feet. Price is depending on lot of other things as well. So that's why we are missing some other variables within the model. If we are incorporating, we are adding more independent variables, those are having the direct and indirect impact on house prices, then easily we can overcome this issue, right? So we can increase the model predicted power. So we can increase the more efficiency of the model. We can increase the strength of our model, right? So that's why I have explained about the R square and also the model. Now the third component is also very important. This is a significant value, right? This significant value usually say p value. So we have a criteria. If the p value is less than alpha, usually we say alpha is 5% or 10%, 1%, whatever your range is. So if this p value is less than alpha, then we can say model is significant, right? So if this is, if this is not significant, then we can say this is this model is not having the impact, significant impact, like the independent variables are not playing a key role to change the dependent variable, right? So now we can say model is significant because the p value is less than zero point zero 0.05. This is straightforward. We can say our model is significant or insignificant. Okay, so I've explained in this output in the three different ways. Of course, we have other ways as well. So we can easily explain the individual significance as well by using these p values. We can also see the confidence interval, lower 95%, upper 95%. Also, we can explain the mean square error we can also mean squares, and also we can explain about the f value. We can also explain the ss, sum of squares. So we have no, a lot of other things to explain, right? But right now we are just understanding the basic concept how the regression analysis behaves. Okay, now we are learning something else. This is the slope is positive. You know why? Because the line is going to upwards, is a positive slope, so a positive trend. So that's why you can easily say we have a direct relationship. Okay, so again, I already explained in detail in the last slide, but again, if you want to understand in the different way, so there is a blue different, this is the different way of explanation. If you want to convert into the 1000 units, then you can explain in another way, right? So you can say like no house had 0 square feet. Yes, true, but there is a 98.24833 dollar value. Just indicate that the house within the range of the size within 98,248,000 is the portion of the house not explained by the square feet. It means that sometimes this is the average value. You know that this is the intercept definition, the average value of the dependent variable when the independent variable is zero. So this is the standard deviation, how you can explain your intercept. So that's why I have given one another example of the fixed cost as an intercept. So you can easily relate the fixed cost as an intercept. So you can understand what is the initial investment you are spending. This is called the cost function interpretation of the intercept. Okay, now this is again we can explain about this. So if 1 unit increase in square feet, the how much the value is actually the increasing in the house price. Why I'm using increasing word? Because this is positive value. If this value, if this sign is negative, means we have negative impact. Right now, here B1.10977 tells us that the average value of the house increased by the 0.10977 1000 unit. If we are converting the 1000 unit with the 109.77 on average, the for each additional 1 square feet for the size, it means that if you are increasing 1 unit in square feet, it means that the house price is increasing with 109.77 on average with your square root. So you can easily understand the basic concepts of regression. So now we are learning the basic concepts. So this is the sum of the residual from the least square regression line is zero. So this is zero, and the sum of square residual is minimum. Like you can say, these are the assumption of regression, least square regression. So if you want to test, you can easily test. I can go through in the next workshop. So if you are having the regression model, you can use the original y value minus y cap. Y cap is the estimated value, and sum of y minus y estimated y is always zero. So you can easily prove this one. And also the sum of the square residual is minimum. So this is standard assumption. So you can easily say like how your regression analysis have the minimum residual value. So we are understanding about the coefficient determination. Already I've explained in detail, which is also like R square also says coefficient determinant. This is a new terminology if you don't know about that. So even sometime the examiner can ask the questions like find the coefficient determination, but sometime you don't understand what is this. But this is the same R square. So R square always lies between 0 and 1. So 0 means there is no contribution of the independent variable, no variation explained by the independent variable on dependent variable. And the 1 means is 100% a contribution of independent variable explaining to the dependent variable. So this is this we can also find R square by using the regression sum of square divided by total sum of square. And we have this kind of relationship, you can say strong or weaker. So if even the strong is we have a direct impact. So direct, of course, indirect and direct both, we can say having the strong means we the value is nearby the one. If the value is nearby zero means a weak relationship. And The one is actually having the strong relationship. Strong, you can say, you can say is strengthen of the model. Again, we already learned about the 58%. What is the 58% say, like our model variation due to the independent variable, non-dependent variables. Now we have activity. So this is about the training houses versus employee performance. So this is we want to check the impact about the performance score. So this is the regression model. For example, we have a regression model performance score is equal to 60 plus 20, 2.3 multiplied by training house hours. So, for example, you want to predict this model for performance score. So, of course, for example, I am the owner of the company. I want to give a more opportunity to learn that my employees need to learn something new. So, I'm conducted a training. So, I'm providing 3 hours training in a day. So if we multiply, putting the three in the training hours, you can easily find the performance score. So always training hours having the impact on performance scores. So you can easily predict accordingly. So I generated some certain questions like you need to think about it, how you can get the training scores. So this is I also given the solution as well. So how like the things actually training can the employees can improve the performance score by increasing the number of training hours? Yes, because this the question's answer is yes. And why and why not? So, for example, the companies are not providing the trainings means the peoples will not understand in the real world scenario. Will the people will not understand the latest things in the market. So, of course, this is very very important. The nowadays this is better to give the more trainings means you can grow, your company can grow faster. So I'm giving you another example, price versus quantity sold. So this is again the example of regression model. If you having the more price means quantity sold, maybe the increase or decrease. Sometimes the price is going high, so peoples are not like quantity sold is going down. So this is just a price versus demand example. So, if you are finding the what does the coefficient negative 15 means? Like negative 15 means we have a negative 15 times impact, negative impact on quantity sold. Fee means if you the price is increasing with 1 unit, so the quantity is decreasing with 15 times, right? So this is the indirect relationship and indirect impact on quantity sold, right? So what business insight can you refer from this relationship? Yes, you can say it's highly negative because sometimes the price is so sensitive, just like in Malaysia. Prices are going high with I'm especially telling the petrol and gasoline prices. These prices are going high means you can face challenges in the market, and the peoples are actually increasing the prices of each and every goods and grocery things to easily maintain the standards of quality. So this is actually for 1% increase in the, yes, already I explained. So 15 per unit decrease in the quantity sold. Okay, so now I'm having another example. This is experience and salary. So you can easily check either the year number of experience is increasing. So then, of course, you will get the more salary, right? So you can. I've generated some of the question. You can go through these questions, so you can easily find how what is the expectations. I'm just giving you some ideas to learn about the regression analysis. So yes, we have a direct impact of number of year experience versus salary. So yes, you can get the answer like 1800 increase per year of experience, and the base salary is 35,000 with the no experience. Yes. So we have another example for retail company. So we have a sales equal 50 plus 6.5 into advertisement budget. So I taken this example from the last week practical activity because I given you Excel file with the different advertisement things. So how you can increase the sale by using different advertisement budget. So right now, a manager plannings to increase the advertisement budget and wants to estimate the expected impact on sales. So of course, yes, you can. So you can set like you want to spend 2000 on advertisement. So you can put the advertisement budget and you can predict the sales, right? So for example, advertisement budget increase by 2. So how much does a sale increase? You can easily put the value as a 2. So you can get the value 13. So we have other solution as well, like in 13,000 increase, you can calculate. So, because this unit is that 1,000 unit, right? So, if you read the question, so a question says we have a sale is in 1,000 unit. Okay, so this is one of the way how to explain. Now, I have another example with retail marketing. So, this is the advertisement budget with the sales. The question is straightforward. So, you want to find the value with the manager is considering allocating 8,000 for advertisement next month and wants to forecast the expected sales. So you are just putting the value, and you if you are just putting this value, and you can easily get the answer, a predicted value. So this is the solution. Right now we are learning with the sales and advertisement. So how if you are spending on the advertisement budget, you can get the sales value. So you can easily find the solution as well. So, for example, what does the coefficient 5.2 indicates? So, this is means like this is the regression coefficient. So, if you are spending 1 unit in advertisement budget, for example, like 1,000 unit in advertisement budget, so the sales will increase with the 5.2. If you're multiplying by 1,000 units, so you can say 50 5,200 times the sale is increasing, right? So this is all over overall the things how you can interpret the different thing. So you can what is the practical meaning of the interpret? So I already explained. So if you are explaining this one as an intercept, so you can easily say like when we are no spending any budget on advertisement, so then what is the expected sales? So now you can say 45,000 sale is expected sale when we are not spending on any advertisement budget. So now we are learning open and revenue. So open hours, and so we I have incorporated so many examples in this workshop to give you some different exposures, so like how you are thinking in a different way of regression analysis, solving the regression analysis problems, just like how to handle the business intelligence scenarios by using regression model. So you can say open hours, hours open and the revenue. So you can easily analyze about the coffee shop and what is the 75 means, what is the 200 means. Already I've explained about that, so you will get the answer as well. Now I'm giving very important uh, lecture to you right now. For example, judge want to take a decision about any case. So the judge can take four different kind of decisions. Like for example, true. True means the person is very innocent, and the accept means the we are accepting. Judge is accepting. Yes, this is innocent. Like this is the correct decision, right? So now the correct decision says when the true is accepted. For example, the false is rejected means this is again a correct decision. So if the fall is rejected and the true is accepted, so this is the correct decision. But again, we have true is rejected. If the true is rejected means we have an error, like we are facing some error. So this error says type 1 error. Type 1 error or alpha error says when we have a true statement. For example, a person is very innocent, and the judge says no, this is not innocent. And also I'm giving one example from the student side. For example, the you are doing a very good job and you answered the question correctly, but teacher says no, this is wrong. So this is called type 1 error, right? Alpha error. So, and also we have a false. False means the person is not innocent, but the judge is actually releasing, and there is no punishment for that particular people. So this is called type 2 error, which is also says beta error. So when we are accepting the false, accepting the false means the person is not good, but we are acknowledging. We said like okay, this person is not guilty, and we are releasing. So this is again an error. So I'm just creating a context how the decision making is going on, and then later on we will learn how to use this concept in the real way. So already you have some idea about the type 1 error, because in the last uh, course you learn about the basic things, like what is the type 1 error. Like you also learn about the alpha error, like 5% and the confidence interval. So this is already you learn with these basic ideas in the previous lectures. Now we're learning about the next concept. So now we have a context like telecommunication companies using business intelligence model to predict whether the customer will leave the company in the next quarter. The company has tested the model on the 1,000 customers and obtained the following results. For example, we have chunks, yes, and the not chunks is 1,000, 100. The T, you must understand the TP, TN, FN, and FN. So this is a negative. Okay, so right now you must understand about this one. TP means true positive. True positive means we are just we are telling about the positive means yeah, positive or negative versus true or negative, right? So we have a true or negative, positive or negative. So there is a positive, right? So true means this is true. This is yes means true. I'm just writing here true, and this is false. So this is positive mean P, and negative means N, right? So you can easily differentiate. So right now TP means true positive, and this is FP. This is true negative, true. Okay, false negative, and true negative. Okay, so I'm writing here again because I think this is I typo issues. This is not good. So this is TP, Yeah, this is true. Already it's written. Sorry, I'm using mouse for this. Okay, this is you can say F false positive, FP, and also here you can say this is T true negative, TN. Please don't consider this because when we are changing the rows into column or column into rows, then the things are different, right? So right now I did the same. I changed the rows and columns, so its meanings are different. So now um, this is called F false negative. Sorry, I'm writing like this, but you need to understand. Okay, so now you can easily understand what is the meaning and you can easily explain. So, for example, what is the meaning of true positive? Already explained in the last slide, right? Hopefully, you remember about the last slide. So, customers who actually churn and were predicted as churn. So, this is again the false negative means the customer who actually churn but were predicted as not churn. So like one is you can easily understand by using this table. So means the true means this is churned, and false means not churned. So true means the customers all have churned, but its positive means predicted churn. So it's a prediction or actual prediction versus actual. You can easily understand. True fall means it's showing the actual, and the on the column side you can say it's a predicted. So we have some questions like we want to find the sensitivity, and we also want to find the specificity. We want to find the accuracy. Now I'm showing you some formulas, and now we will find the values of these particular sensitivity, specificity, accuracy. Right now, for example, I want to find this sensitivity. It's a very simple formula. We have TP, true positive divided by true positive plus false negative. You can easily just solve it, and then you can get it's a 85.71% sensitivity is there. So if you want to find the specificity, the specificity formula is 2 negative divided by 2 negative plus false positive. So which is 84%. 84% also says 84% specificity, and our accuracy is again 85%. So you can explain the accuracy, specificity, and sensitivity in the very easy way by easily calculate. So you need to calculate manually, or you can use the calculator during your exam. Now it's your turn to calculate, and I'm giving you some times to calculate. So you need to submit at the end by using the available uh, link. So you can use this formula on the right side. You can easily find these formulas and fill the values, and you can find the. So I already given you the solution for this question. This is a sensitivity, this is a specificity, this is a accuracy, and this is a negative predicted value if you want to find, and this is precision if you want to find. So all the formulas are there. There are five different formulas. You can easily find it. So, and this comprehensive table and formulas are there. So I will not provide the formulas during the exam. You need to memorize the formulas. Now, this is your time to solve and just send by using this click. Uh, Thank you very much, everyone. So if you have any questions, let me know, then we can discuss. Thank you. Have a good day.